Good evening, all. Today we are going to learn a topic in power system analysis, and the topic is need for planning in power system. So, before starting this topic, what is meant by a power system? So, power system is an electrical network which combines generator, transformer, transmission line, bus bar as well as load. So it is majorly categorized into three parts: generation, transmission as well as distribution. So it is an electrical network. And next, planning. To achieve something we need to plan. So it is very important in our day-to-day life. So similarly in power system, to achieve some milestone, we are in need to plan. Increasing the generation or increasing the loads or increasing the transformers, we need a plan for the power system. Next, the power balance equation. So it clearly defines the generation part as well as the demand part. So here PD is called as the power demand by the consumers, and PGI is the power generation by the generated unit. PD equal to sigma PGI. So total demand must be equal to the generation so that the power will be in a balanced condition. And next, the power system must be reliable and uninterrupted for the consumers, and the load must be fed at constant voltage as well as frequency. So the electrical areas are large in size, so planning for future expansion is must in a power system, so that we need the data required for the transmission, generation as well as the distribution while planning a power system, so that the power engineer uses computer programming. And major importance of the planning and operational analysis covers the maintenance of generation, transmission as well as distribution. The block diagram shows about the basic block of a planning. So initially, planning related to generation, transformer as well as transmission, all the components is required. And next, according to our plan, we are implementing the plan. And next is the monitoring and comparing plans with the result. So we need to monitor regularly about the power generation and how much it is distributed. And we are going to compare it with the previous result. If there is not any deviation, we can entirely plan and implement the system, and if there is deviation, we need to undergo various corrective measures, and again we need to plan, implement, and again we need to monitor. So this is a cyclic process which is used while planning a power system. So the steps which is used in the block diagram is mentioned again. So planning of power system, implementation of plan, monitoring of the system as well as compare with the previous result. And next, analysis. So in a power system, so we are generating and we are transmitting and distributing to the load or the consumers, and in between that we need to analyze how much the generating unit get generated and how much the power get transmitted as well as distributed, and the particular analysis is classified into three types. So first one is a load flow analysis, second is short circuit analysis, and the third is transient analysis. So let's see one by one. So first is load flow analysis. It can be also called as power flow analysis. It is used to determine the voltage, current, real power, reactive power, and frequencies of the power in the power system. And next, the operating condition can be analyzed including the contingencies such as loss of generators, transmission line as well as transformers. If the voltage level get varies, or if there is any losses in the generating part or transmission or transformer part, so the voltage level will increase. And the result of this particular analysis is to determine the optimum size and location of the capacitor for the power factor improvement, and this results in the stability analysis. So for a load flow study during the planning of a new system is completely required and it is essential. So this is also needed for the evaluation of effect of different loading conditions of an exciting system. And the next is short circuit studies. Short circuit study in a power system causes increase in the voltage or current and creates abnormal or faulty conditions in the power system. The short circuit studies are performed to determine the magnitude of the current flow throughout the power system at various time intervals after the fault. So this can be analyzed using pre-fault voltage as well as post-fault voltages. And the magnitude of current flowing through the power system after fault varies with time until it reaches the steady state condition. The main objective of the short circuit analysis is to determine the current as well as voltage levels at different locations with different types of fault. And the various types of fault are phase to ground fault, line to ground fault, line to line fault, double line to ground fault, as well as open conductor fault. While analyzing the short circuit studies, it is very much required to select the fuses, protective relays as well as circuit breakers to protect the entire power system from the abnormal condition. So the symmetrical components and the network, sequence network are used in the analysis of the short circuit studies. Next is the transient stability analysis. Transient means changing of state, that is within a short period the system will change from one condition to another. It is called as a transient. So in power system, the stability depends upon the power flow pattern, generator characteristics, system loading level as well as the line parameters. And the stability can be divided into two types. One is steady state stability and the other is the transient stability. And the steady state stability is defined as the ability of power system to remain in synchronism following relatively slow changes or continual changes in the generation part. And next is the transient stability. It is defined as the ability of power system to remain in synchronism under large disturbance condition such as fault as well as the switching operations. The maximum power transfer limit is less than that of the steady state condition. So the transient stability studies are conducted when new generating units, new transmission units are planned, and these studies are helpful in determining the nature of protective system needed, critical clearing of the circuit breakers, voltage level as well as the transfer capabilities between the system. So overall, in a planning of power system, we need various analysis part. So that is load flow, short circuit as well as the stability. So overall, we have learned why planning is required in a power system and what are the various analysis which comes under a power system for the better transmission of the power from generating part to the consumer side. Thank you.